Welcome to day 3 of the Mol homework. Today we're going to work on empirical formulas and molecular formulas. Remember that there's a little tune that we memorize in order to do these empirical formulas, and it goes percent to mass, mass to mole, divide by smallest, then make whole. So I'm going to use that every single time so that it hopefully gets stuck in your brain. So we'll start here. Our empirical formulas. This is on page 14. There you go, page 14 of your homework. And number 3 is where I'm going to start. So the tune goes percent to mass. Well, this is already in mass. If you see G, that stands for grams. That means it's already in mass. So we've already done step 1, percent to mass. It was given to us. Then we go mass to mole. So that means I have to divide each one of these mass amounts by its molar mass. So I start with iron, 83.91 grams of iron, and I need to go to moles, which means that I need to divide by the molar mass. So I find the molar mass on the periodic table for iron, right there, 55.845 is the molar mass of iron. So I divide by 55.845 grams of iron. And let's see, I get 83.91 divided by 55.845 gives me 1.502. 1.503. Actually 1.50 would be fine, but let's go ahead and do that. So that's 1.503 moles. Now I need to do oxygen next. 36.08 grams of oxygen divided by the molar mass of oxygen on your periodic table. 15.999. Let's see what that is. 36.08 divided by 15.999 gives me 2.255. 2.255 moles. Okay, so we've done percent to mass, right there, mass to moles, divide by smallest. Well, that's the smallest mole amount, so I'm going to divide each of these by 1.503. This is going to equal 1. This is not going to equal 1. So 2.255 divided by 1.503 gives me 1.5. Okay, so we did percent to mass, mass to moles, divided by the smallest, then make whole. Well, that is already a whole number, but that is not a whole number. So in order to make that a whole number, we need to multiply by whatever's the smallest number that we can to make that into a whole number. Well, the easiest way to make 1.5 into a whole number, you cannot round. You can't round. You have to multiply by something. So we're going to multiply by 2, because that's going to give me 3. And 3 is a whole number, right? Yep. So if I multiply this by 2, I have to multiply this by 2. So that's going to equal 2. So that gives me my coefficients. Okay? The coefficient for iron is going to be 2, and the coefficient for oxygen is going to be 3. So that is my empirical formula. Alright? So the next one we're going to do, it's not already in mass, so we have to go percent to mass. Percent to mass is just changing that percent sign to a G, 67.6 grams of mercury. And 10, I'm trying to make sure I have plenty of space, percent to mass for that is going to be 10.8 grams of sulfur. And percent to mass for that one is 21.6 grams of oxygen. So we did percent to mass, now we have to go mass to mole. So it means I have to divide by molar masses. So the molar mass for mercury, 200.59 grams. Okay, let's see, 67.6 divided by 200.59 gives me 0.337 moles. So we did percent to mass, mass to moles. So we have to do that for each one. So I find the molar mass of sulfur on my periodic table, 32.0, here we go, I'll point to it for you, 32.066 grams. 32.066 grams. Let's see what that's going to be. 10.8 divided by 32.066. It's 0.3368, 337, 0.337 moles. Okay, so I did percent to mass, mass to moles. Got to do it for the last one, for oxygen. I may not have given myself enough room here. So let's see, divided by 15.999, because that's the molar mass of oxygen, which you've probably already memorized. So 21.6 divided by 15.999, 1.35. 1.35 moles. So percent to mass, mass to mole. Divide by smallest. Well, both of these are pretty small. Definitely smaller. So I'm going to divide both of these by 0.337. Divided by 0.337. Divide that thing by 0.337. So let's see what that is. 1.35 divided by 0.337. Oh, that's not going to work. 0.33. Wow, I'm just not going to be able to do this, am I? Divided by 0.337. Ha! It's 4. Okay, sorry about the calculator malfunction there. Couldn't seem to operate. Operator error, not calculator malfunction. It's operator error. So look what I got. I got 3 whole numbers. Okay, so we did percent to mass, mass to mole, divide by smallest, then make whole. Well, we don't need to make them whole because they're already whole numbers. So mercury's subscript, see that's subscripts right there. Mercury's subscript is 1, which we don't have to write a 1. Sulfur's subscript is 1, which we don't have to write a 1. And oxygen's subscript is 4. What's SO4? Right, that's sulfate. This. So it's like that. All right, that's our empirical formula for mercury sulfate. So going on to page 15. Let's see, I picked this one down here. Another empirical formula. So we'll go percent to mass because these are all in percentages. So I'm going to go percent to mass first. 56.6 grams of potassium and 8.68 grams. Remember, all you're doing is changing percent to grams of carbon. And 34.7 grams of oxygen. So we did percent to mass. Now we'll do mass to moles. Okay, so that means I have to divide by the molar mass. Find the molar mass of potassium on your periodic table, 39.098. Let's see what that comes out to be. 56.6 divided by 39.098. 1.448. Let's try that. 1.448 moles. So let's try the next one. Carbon. 8.68 grams of carbon divided by the molar mass of carbon, 12.011. 8.68 divided by 12.011, 0.7226, let's do 0.723, 0.723 moles. Then oxygen divided by 15.999, and 34.7 divided by 15.999, 2.169 moles. Alright, so what we do, I'm not able to get all of it on there. Let me see if I can make this a little higher so you can see the whole thing. There we go. So we did percent to mass, mass to moles for each one. Now we need to divide by smallest. Well, that's the smallest mole amount. So I'm going to divide everything by 0.723. By 0.723 and divide that by 0.723. That is going to be 1. Okay. 1.448 divided by 0.723. 2 gives me a whole number. If you've got close to a whole number, you need to go with that. And then let's see what this one's going to be down here. Give myself a little bit of room here. Okay, 2.169 divided by 0.723. Whew, 3 on the nose. Okay, so these are my subscripts for the empirical formula. So let's see what that comes out to be. So let's see. Potassium has a subscript of 2. Carbon has a subscript of 1. I have to write the 1. And then oxygen has a subscript of 3. Look, what is that? What is CO3? It's a polyatomic ion. It's carbonate. It's potassium carbonate. Alright, going on to page 16. I'm doing a couple on here because we need to do, we're going to do molecular formulas. We're going to do this extension with doing molecular formulas. So in order to do a molecular formula, you have to have an empirical formula first. So we'll do number 6, which we have to do both for number 6. It goes, an unknown compound is analyzed and found to consist of 49.0% carbon, 2.7% hydrogen, and 48.2% chlorine. If the molecular mass of the compound is 150, that's an important piece. What is the molecular formula of the compound? Well, it's only asking us for the molecular formula, but you can't get this without doing an empirical formula first. So we need to do the empirical formula for this first. So we'll go percent to mass. So for carbon, it's 49. Can you see that? Nope, you can't. There we go. 49.0 grams of carbon. Let's see, what else do we have? 2.7 grams of hydrogen. And we have 48.2 grams of chlorine. Okay, we did percent to mass. Now we need to do mass to mole by dividing by the molar mass. So the molar mass of carbon, 12.011 grams. Uh, 4.08. Let's go 4. I don't like that. Let's do 4.0796. 4.0796. Okay, so here's my reasoning why. The more numbers I have, the more precise, here we go, more numbers I have, the more precise my calculation is going to be. And this, if I started rounding here, if I did 4.0795 and I rounded this, that would mean that would be 4.08. That cuts off too many digits for my comfort. So I'm going to leave those digits because remember, you don't have to round anything anyway till the end. I could technically take all these digits if I wanted to. I'm not going to. So I'm going 4.0796. So let's see, hydrogen's molar mass is 1.008 grams. And let's see, 2.7 divided by 1.008 gives me 2. There's a thing on my 6. 2.6786. Yep, that's what I'm going to do. 2.6786. I'm going to round right there. I'm going to keep a bunch of digits on this one. Put moles next to it. Duh. And then for chlorine, the molar mass of chlorine, 35.453. 35.453 grams to get the moles of chlorine. So 48.2 divided by 35.453 gives me 1.3595 moles. Alrighty, kids. We went percent to mass, mass to mole. Now I need to divide by the smallest one. So that's the smallest mole amount. So I'm going to divide each one by 1.3595. Okay, let's see, 2.6786 divided by 1.3595. Okay, I got 1.97. I'm going to round that to a 2. That's not far enough off. If it was 1.75, I wouldn't round it. If it was 1.8, I wouldn't round it. If it was 1.8 or higher, I'd probably go back and check my math. But this thing, 1.97, is close enough to 2 that I'm comfortable rounding that to 2. Okay, next one, I need to divide by 1.3595. Let's see what that comes out to be. Probably something wacky. 4.0796 divided by 1.3595 is 3. Thank goodness it's not something wacky. 3. So I have my coefficients here. There's carbons, there's hydrogens, there's chlorines. So my empirical formula is going to be C3H2Cl, and Cl is just 1. Okay, that's my empirical formula. I had to get this in order to do my molecular formula. When you're trying to get a molecular formula, you need to have that molecular formula's mass. In order to go from an empirical formula to a molecular formula, I have to use the masses. So first thing I'm going to do is I'm going to calculate the mass of this. So the mass of this thing, so that's going to be 3 carbons. Okay, I'm going to use some space down here. Okay, carbon times 3. Okay, it's 36.033. Hydrogen times 2. And that's 1.008 times 2, 2.016. And chlorine times 1. And I'm going to add them together. So 36.033 plus 1.008 plus 35.453 gives me 72.494. So that is the mass, 72.494 grams per mole. I have to use that mass and this one in order to get the empirical formula. I'm sorry, the molecular formula. So what I do is I take the molecular formula mass, so the molecular formula mass, and I divide it by the empirical formula mass. So this is 150 because it was given to me right here, divided by this, 72.494. 150 divided by 72.494 is 2.069. Usually it's high, it's a little bit closer, but it's 2.0, so that's close enough. Okay, so I have to multiply each of these subscripts by 2 to get the molecular formula. So the molecular formula will be C times 2. So that's 3 times 2 is 6. C6H4Cl2. And that's how you do it. Okay? You multiply each of the subscripts here in the empirical formula by the number that you find when you divide the molecular formula mass by the empirical formula mass. Okay? So let's do another one down here just to make sure you got it, because it's probably a little fuzzy still. So let's do another one. It says a 24-gram sample of a substance is made up of 15.42 grams of carbon, 1.726 grams of hydrogen, and 6.850 grams of oxygen. If the molar mass of the substance, we'll need that number, if the molar mass of the substance is 168.19 grams per mole, what's the molecular formula? Okay, so we got an empirical formula first. All right, this, not really important. This, definitely. So we'll start out the way we always do. Percent to mass. Well, they're already in masses, so I don't need to worry about that. So it's 15.42 grams of carbon and 1.726 grams of hydrogen and 6.850 grams of oxygen. So percent to mass, mass to mole. So we need to divide by the molar mass. 1.284. Okay, moles. So we're going to divide this by the molar mass of hydrogen, which is 1.008. Uh, 1.712. 1.712 moles. And then this oxygen divided by 15.999 grams, molar mass of oxygen. 6.850 divided by 15.999, 0.428 moles of oxygen. Okay, so we've got percent to mass, mass to moles, divide by smallest. Well, that's clearly the smallest. So divide everything by 0.428. It's going to equal 1. 0.428. Let's see what that is. 1.712 divided by 428. 4. Ooh, 4 on the nose. I like it. Okay, then the next one, divided by 0.428. 1.284 divided by 0.428. Oh, it gives me a solid 3. I love it when I get those solid numbers. Okay, so those are the subscripts for my empirical formula. My empirical formula is going to be C3H4O. That's my empirical formula. Okay, I've got the molar mass, so I've got the mass of my molecular formula. So it's 168.19. And I'm going to divide it by the mass of the empirical formula. So that means I have to get the empirical formula's mass. So C times 3, H times 4, and O times 1. Let's see what each one of those is. Sorry about that. That was husband. 12 times 3, 36.033. Hydrogen times 4, 1.008 times 4, 4.032. And oxygen times 1 is just 15.999. So I add those together to get my empirical formula's mass. 36.033 plus 4.032 plus 15.999 gives me 56.064. 56.064. So that's the empirical formula's mass, which I'm going to use right here. 56.064. And let's do that math. 168.19 divided by 56.064 gives me, what do you think that rounds to? Yup, a 3. So that means I'm going to multiply each coefficient here by 3 in order to get the molecular formula. So, let's see, that would be C9, 3 times 3, H12, because it's 3 times 4, and then O3. That is my molecular formula. Okay. Yes, I realize it's a lot of work, but this is work that you can do. This is pretty easy math. I think the hardest part is getting the empirical formula, really, but you have a little rhyme to do that. Remember, it's percent to mass, mass to mole, divide by smallest, and make whole. Do your best with them. Remember that when you've got these mole amounts, if you do have several digits, it can make it easier. You know, you don't have to round it. I wouldn't round them, definitely. So if you have questions, make sure and ask, and good luck.